Hi and welcome to today's video where we are going to continue our journey with fractions. Specifically today we are going to be looking at the addition and the subtraction of fractions. Now this video is going to walk you through how to go about doing it, and I'm going to describe why you would need to go about doing this as well. So let's get started. First thing we're going to do is we're going to deal with green, and we're going to deal with the addition of fractions. Now as you can see here, we are comparing 1/8 and 2/4. Now there's a problem with that. Imagine if you were, I don't know, splitting something. Let's say this is a visual representation of what it is that you're going to be splitting. And if this was split into eighths, 1, 2, 3, 4, 5, 6, 7, 8, one person would be getting this, and then another person would be splitting it into quarters. So they would be splitting it into pieces that are significantly larger, and they would be getting 2/4. So they would be getting that much. Now when you look at that, you might say, whoa, wait a second, that means that person number 2, whoever's getting 2/4, is getting more than the person who is getting 1/8. And that is technically correct, but you can see the size of the pieces is much, much larger when you're dealing with quarters. And when we're dealing with addition and subtraction, we can't do that. We want to try to keep things as fair as possible and deal with the same size pieces. So the first step that we're going to do is we're going to look at the size of the pieces. We're going to look at the denominators. And we're going to see here that 8 is smaller pieces than quarters, as I've drawn out right here. So what we need to do is we can't really make eighths into larger pieces, but what we could do is we could take and cut our quarters into smaller pieces. So I can just kind of split that there and there. Now, how do we do that mathematically? Well, simple. What we do is we manipulate this fraction a little bit. And if you've watched a previous video, I talked about creating like denominators. And like denominators means that we get to manipulate the fraction so that it is what we call equivalent. So it means the same thing. So if I was to take and multiply this fraction here, I could probably get the same number as over here. So there is something I can multiply 4 by to get 8, and that would be 2. Now, what we need to do is we need to remember that if we are cutting fractions, like I did up here, you'll notice that when I cut this, I did cut the bottom number, but I also cut the top number. I was able to cut this into smaller pieces as well, my selection. So I need to remember that when I multiply the bottom number, I need to multiply the top number by the exact same thing. So in this case, I split it in half, or I multiplied it by 2. Now wait a second, that sounds a little bit weird. When I multiply, I'm technically making things smaller. So on the flip side, when I divide, I'm making things larger. That is a concept that a lot of kids really struggle with when it comes to fractions, is that when we're ingrained to think that multiplication is going to make things larger, and yes, it does make the number larger, but that number, as we just looked at here, even though it's a larger number, it technically is a smaller piece. So remember that as you move forward. So back to this. Let's change this fraction to an equivalent fraction. So what we have here is 1/8, and we're doing nothing with it because I can change this one to make eighths. So if I multiply 2 times 2, I end up getting 4. And if I multiply 4 groups of 2, I get 8. So now that has changed my fraction from 2/4 to 4/8. So now what I want to do is now that I have the same numbers, I want to put the fraction back together. So I'm going to have 1/8, and I'm going to be adding 4/8 to it. And what you'll do next is, and this is the important part, is that you're only adding the top numbers. So if you take a look here, I had one piece there, then I had a piece here, a piece here, a piece here, and a piece here, and they're all the same size now. So if I look at that, I've got 5 out of 8. Now, why did I only add the top number and not the bottom number? Because the size of the pieces didn't change. I didn't change the overall size of the bottom pieces or the denominator. There still is 8 pieces, but what I did was I brought these 4 and this one together to look at how much I had in total. So I'll recap that real quickly. So step number 1 is what we want to do is we want to look and see if there are common denominators, and in which case there are not. Then step 2 would be to make common denominators using multiplication. or division if you can, but you can't divide 1 in this case. So if I multiply 4 by 2, I get 8, and that gives me the same denominator right here. Then I multiply the top by 2 as well, because what I do to the bottom, I have to do to the top, and I ended up with 4 out of 8, or 4/8. Step number 3 would be to add the numerators together, which would give me 5, and then I keep the denominators the same, because the denominator does not change size when we're adding. So when I had 1/8 and I added 2/4 to it, I actually ended up having 1/8 plus 4/8, and I ended up with 5/8 total. Now let's switch over to subtraction for a second. When we're looking at subtraction, subtraction works exactly the same way as addition. What we want to do is we want to look and try and create common denominators first. And if I look here, I've got a fifth and a third. Now there's a problem with that. I can't multiply 3 by anything, by any whole number, to equal 5. And I can't divide 5 by anything to equal 3. So if I can't change one, well then I have to change them both. And what I want to do is I want to I'll use the simplest number, I'll just multiply them by each other. Because if I have 5 and multiply it by 3, it's going to equal the same as 3 multiplied by 5. So what I'll do is I'll multiply this by 3, and this by 3, and this by 5, and this by 5. Now you'll notice that I can multiply these numbers by anything. I don't have to be 5 and 5 or 3 and 3. I don't have to do that. What I want to do though is I want to make sure that the goal is that these denominators, or the size of the pieces, is the same before I add or subtract. So let's do this multiplication here and simplify this. So I've got 3 times 3, and that's going to equal 9 out of 15. And then I've got 5, because one group of 5 is 5. And I've got 3 times 5, which is 15. And now if you take a look here, what I have is I've got 9 minus 5 and 15ths. Now, much like addition, you're not going to adjust the denominator. You're only going to subtract the numerator. So in this case, I know the denominator is going to be 15ths. And I can see that if I take 9 and subtract 5 away from it, I'm going to end up with 4. All right, so that is addition and subtraction. There is one more piece that I want to tell you that doesn't necessarily work here, and there's a missing step. The last step when you are adding or subtracting fractions is that you want to make sure your fractions are in lowest terms. Now what that means is that if these numbers were divisible by the same number, I could shrink it down. So for instance, 2/4, if I divided it by 2, I would end up with 1/2. Okay, so don't forget lowest terms. You're always going to want to work with the smallest numbers possible. Okay, so that is adding and subtracting fractions for today's video. If you saw something that didn't make sense, by all means go back and rewatch the video. You are more than welcome to comment if there's something that was confusing. I'll gladly get back to you. And don't forget to share and subscribe. Thanks very much.